In this video, we're going to look at energy in physics and how to take a beginner's approach to understanding it and a few different types of energy. So this may look like a set of notes, and it is because this is how I typically teach it. So as we go through it, just kind of hang in there with me. To begin, normally I ask my students, what is energy? And I want them just to kind of take a second and draw it in the box. So think for just a second about what is energy if you had to think about it. Okay, so I'm just going to help you. A lot of times I get sunshines. A lot of people love to draw sunshines. A lot of people draw batteries. And whenever they draw batteries, they may do a AA or a AAA or something like that. Sometimes I have somebody like running really fast. We're going to pretend like they're running. That doesn't really look like it. We're going to pretend. Anyways, there's lots of different types of energy. You may think about like a fire. Some people draw like a fire. Lots of options. So here's the thing. Energy, all of these options, is just the ability to cause change. So, for example, the sunshine can change that you can see. It can change the temperature outside. A battery can make a toy actually make noise, or a fan actually run, or a flashlight turn on. You running, you are moving from one place to another, so that's your change in position. Your temperature may change too. You get hotter as you keep going. Things like that. So energy is just the ability to cause change. Now, here's something that's important. Whenever we've been talking about in our physics stuff, physics is just taking math and applying it to the real world. And so a lot of times we talk about things either being scalars or vectors. Vectors are when directions matter. Energy is actually a scalar quantity. And so if it's a scalar quantity, that means the direction will not matter. So all energy is measured in joules. The joule is actually named after James Prescott Joule. He lived in the 1800s and he did a whole lot of cool science stuff around heat and electricity and all that kind of thing. So because of that, they named the joule after him. We use a capital J as a joule. Now, a joule is actually a kilogram times meter squared per second squared. So that's a lot of units to keep up with. So sometimes whenever we have like too many units to really keep it, we can merge those into another unit, such as the joule, that really is embodied all of these things. So every time we talk about a joule, all the math will really prove all of those other things right here. So it is the standard, the SI unit for energy. So there are lots of different types of energy, and I typically get my students to list those. So now I'm just going to talk about the ones we'll do in here. We're going to talk about mechanical energy. We're going to look at gravitational potential energy. We're also going to look at spring and elastic potential energy. And we're going to look at kinetic. So notice real quick, I didn't talk about heat. I haven't talked about light. I haven't talked about sound. I haven't talked about a lot of different types of energy that are the ones that we probably really mentioned up here at the top. So just because it's not mentioned in this one doesn't mean that it's not physics, but it's not beginner physics, and it's not what we're going to look at right now. So let's start by talking about kinetic energy. Kinetic energy is energy in motion or moving energy. So whenever we think about kinematics, like we've talked about before, kinematics is the study of motion. So this means that anything that is moving is going to have kinetic energy. So kinetic energy of the object is going to depend on two things: its mass and its velocity. So think about if you have a ball and you're standing over here and you want to see how strong or how much kinetic energy you can have whenever you throw it at your friend. And so let's think about if you just started with a paper wad. It's a big ball, but it doesn't have a lot of mass, and you can throw it really hard over there at your friend, and it's really probably not going to make a big difference. But then if you took another ball and you did the same thing, like a golf ball, and you threw it at your friend at the same speed, they would say, ow. And so whenever you think about that, so you can almost think about whatever energy is, we go back to our original discussion. It's the ability to cause change. In this case, it's the ability for you to change how that person feels. The paper wad right here has more more space, but it actually has less energy because it changes their opinion of you the least. However, that golf ball, when you throw it at them, it changes their opinion of you a lot if you throw it hard. Now, you can gently throw it at them. They're like, okay, fine. But you won't put as much speed or velocity on it. So here's your thing. Velocity and mass are the things that change their opinion of you. So because they're changing, they have more kinetic energy. So here's your kinetic energy equation. Kinetic energy equals 1/2 mass times velocity squared. Now, one quick thing to note is sometimes people may put a KE for kinetic energy, but it means the same thing, and those are kind of grouped together. But on some equation sheets or some textbooks, they may just leave it as just a K. For the most part, in all of physics, you should use the same variables. But on some occasions, you may see them written slightly different, and it's okay. So in this case, we're going to do a K for kinetic energy. Again, is equal to 1/2 times the mass times your velocity squared. Now be careful, make sure you do not forget that your velocity is squared. Now again, we got to have our unit. So remember, our unit for this, for any type of energy, is going to be the joule. So we're going to use a J. 1/2 is just a 0.5. It's just a constant, so we're going to keep it right there. Mass is going to be measured in kilograms. If it is not in kilograms, you have to change it. And then velocity, just like always we've done before, is meters per second. So let's look at these these problems down here at the bottom. A 1,660 kilogram car travels at a speed of 12.5 meters per second. What is the kinetic energy? If I look at my problem, I'm always going to start by looking at the numbers and what does the unit tell me. Because I see the kg, that means that's my mass. Because I see the meters per second, that's my velocity. Now remember, we said that this is scalar, and so because it's scalar, we don't care if this is moving left or right. So it can be a speed. It doesn't technically have to be velocity having its direction. And we're looking for the kinetic energy. As always, I want to start by writing my equation. Once I have my equation, I want to plug in the things that I know. 0.5 times 1660 times 12.5 squared. And then at the end, I'm just going to plug in my numbers and find my answer, which is a really big number, and that is okay. I get 129,687.5 joules. And that's it. Now, whenever you're dealing with energy, a joule is not a lot of energy. It's not. And so because it's not a lot, whenever you're dealing with big things like a car, it is totally fine that you get a big answer. And if you get a big answer, don't be surprised. Totally cool. So then, let's look at the next one. Daniel is running at 2.8 meters per second. So we know right now, it's going to be a lot smaller thing because Daniel is going to be smaller than the car and his speed is going to be less than the car was too. But they tell me if his current kinetic energy is 254.8 joules, what is his mass? So let's backtrack. Again, we're going to start by identifying the things that we're given. There's my velocity because it's meters per second. This is his kinetic energy, and I'm asked for the mass. So start again with your equation. Once you have your equation, plug in the things you have, and then we have to solve it. Now, this one is going to take a little bit more mathy skills because you're doing something, you're solving for your variable, but that's still within some of these other things. Now, all of this side over here is being multiplied. So I can go ahead and do 1/2 times 2.8 squared based on the commutative property of multiplication. And I get 254.8 equals 3.92 times my mass. Divide 3.92 on both sides. And whenever you're done, you should get your mass is 65. And mass is measured in kilograms. So there we go. One last example using kinetic energy. A race car has a mass of 1,500 kilograms. What is the speed if the kinetic energy is 2.7 times 10 to the 6 joules? So again, right here, there's my mass because it's got kilograms. And then here's my joules, so that's my kinetic energy. They also said KE is the kinetic energy, but I'm just going to use the K because that's what my equation says. It means the same thing. They asked for the speed, and we know speed and velocity right now are kind of interchangeable whenever we're talking about energy. So, equation. After my equation, I'm going to plug my points in. And now that my numbers are in, I can try and solve for my velocity. Now, one quick thing. Don't be scared whenever people start giving you equations or problems that have numbers in scientific notation. Remember, scientific notation is just how you write really big or really small numbers. And that just means it's a big number because it's got a positive exponent. So don't worry about it. Your calculator should be able to handle it. If you need to, make sure to always put it in parentheses first. Or if you're going to divide it by something, always use the fraction bar, not just the divide button, to make sure that all of that's in the numerator. So my first step is to multiply 1/2 of 1,500. Half of 1,500 is 750 times my velocity squared. And again, we're going to keep this over here. Now to get the velocity squared by itself, I've got to divide by the 750. So whenever I do, 750 on both sides. My calculator gave me 3,600. Remember, that is the same thing as 3.6 times 10 to the third power equals velocity squared. Now, please don't stop here. You can't stop here because the velocity is not by itself yet. The velocity is still being squared. So be careful. So then to get that velocity by itself, you have to think about what is the inverse operation of squaring. Well, that becomes a square root. So we got a square root both sides, and my velocity is going to be 60. Now, remember when you square root, it could be either a positive 60 or a negative 60. And the reason why this matters is you could be going left or you could be going right. But the reason why we have to pay attention whenever we're doing that squared is, again, with energy, it gets rid of the negatives because we're talking about speed. But with your V for velocity, velocity cares whether you're going left or right or up or down. And that may show up in one of your later problems. So for now, we're going to pause on the energy section because I don't want these videos to be too terribly long. We talked about the overall, what energy is, a couple different types. We've looked at kinetic energy, and in the next video, we're going to talk about our potential energies. Thanks for joining.